part 2. So in part 1, we came to know about what is undamped oscillation and what is damped oscillation. Again, we learned what is forced oscillation. In forced oscillation, we have to provide an external periodic force to maintain the same type of amplitude. Now, we will come across a new term called damping. So, damping means very simple. Just now I told you that, see, here what is the amplitude of oscillation? Suppose this is plus 5, this is what? Minus 5, here also plus 5, minus 5, same amplitude. Then it is called what? Undamped oscillation. Undamped oscillation. But because of the presence of the external force, or because of the presence of external resistive force, what happened to the amplitude? Amplitude goes on decreasing and finally comes to rest. And that effect is called what? Damping. So very simple. Damping means what is happening here? Amplitude 5, 4, 3, 2, 1. Amplitude decreases. So then based on this we can define what is damping. So damping means it is the decrease in the amplitude of oscillation. Whenever there is decrease in amplitude of oscillation, we say that what? Damped oscillation, and that phenomenon is called what? Damping. Now, another example, take the case of a spring. A box is there. This is the main position of the spring. The spring has some force constant or spring constant. Notation is K or C. C is the spring constant. Now in the beginning, the spring is at the point O, that is called what? Main position. That is called the main position. Now from this position, what I did, I pulled the block through a certain distance. From here, I stretched this one. So this is the new position of the block. So how much is the extension produced? From here to here, the extension is X. Initial position of the spring is the first figure. Second figure what? I pulled this spring through a distance X. Then, in this situation, we can apply Hooke's law. What is Hooke's law? The restoring force equals minus C into X. This is Hooke's law. So according to Hooke's law, we can say the restoring force is minus C into X. What is C? C is the spring constant. Depends upon the nature of the spring. And what is X? Extension produced. So one thing is clear. When I pull this spring, the spring is subjected to one kind of force. What is that? Restoring force. That is the first force acting, restoring force minus X. Other than that, one more force is acting on the spring, and that is called what? Damping force. So second force is called what? Damping force. Now I'll repeat. What is the first force? There are two types of force is acting on the spring. First one is called what? Restoring force. That restoring force we are getting based on Hooke's law, because we know that restoring force is equal to minus C into X. X is the extension and C is a constant called spring constant. Another one is called what? Damping force. And damping force is given by the equation minus gamma times V. And V is the velocity of the spring or the block. V means velocity. V means velocity, and gamma. Gamma is a constant, and that constant is called damping coefficient. It is called a damping coefficient. So whenever a spring is pulled through a distance x, main two forces are acting. First one is restoring force and the second one is called what? Damping force. So conclusion is, when a spring is pulled through a distance x, there are two forces acting. One is restoring force, we have the equation minus Ex. Second one is called what? Damping force, which is equal to minus gamma into E. What is V? Velocity of the block or spring, and what is gamma? Is a constant called what? Damping coefficient. It is constant for a given spring. Now we start the derivation. Based on this, we are going to derive the differential equation of a harmonic oscillator. So we start the derivation. We are starting the derivation by recollecting that in this situation there are two forces acting on the spring. What is that? Restoring force and damping force. So we can write force acting on the spring equals, first one is what? Minus Cx. Then one more is there. You have no need of this figure. And another one again. Force acting on the spring. One is minus X, which is called to what? Restoring force. One more force is that. What is that? Force acting equals minus gamma V. And we know that always the net force acting on a system should be equal to what? 0. So we have, while comparing, this is first force, this is the second force. Therefore, what I can write? F is the force acting on the system, which is equal to, what are the two forces? One is minus Cx and the one is minus gamma V. So F is the force acting on the system, and that force is equal to what? First one, restoring force, another one is what? The damping force. Now from here onwards we will give some substitution. Based on that we will be getting the final result. Now we know that F is equal to mass into acceleration. So instead of F, what I will be writing? Mass into acceleration, which is equal to minus Cx minus gamma V. Now bring to the right hand side, left hand side, this minus changes to plus. So what will be getting? Ma plus Cx plus gamma V equals what? 0. Now instead of A, we learned in lower classes. What is A? A means acceleration. But A equals acceleration, which is equal to what? dV by dt, rate of change of velocity. This we know. So instead of A, what I will be writing? dV by dt. Also, velocity equals what? dx by dt. So instead of A, what I will be writing? dV by dt, but V equals what? dx by dt. So what is the equation for A? Therefore A equals d by dt of, instead of V, what I will be writing? dx by dt. Because A equals d by dt of V. d by dt of V. What is V? dx by dt, which is equal to d square x by dt square. So you got the expression for A. Now instead of A, what I will be writing? This value. Therefore this equation becomes Ma, instead of A, what I will be writing? d square x by dt square plus Cx plus gamma V. What is V? Instead of V, what I can write? dx by dt, which is equal to what? 0. Now divide this equation with mass. So when you divide this value divided by m, so get cancelled. d square x by dt square plus Cx divided by m plus gamma delta x by t divided by m, which is equal to what? 0. So you got the second order differential equation d square x by dt square plus gamma. So I can rearrange this one. D square x by dt square plus gamma by m dx by dt plus c by m into x is equal to 0. Now I am giving one substitution. Instead of c by m, d square x by dt square, cx by m, gamma m by dx square. So what I can do is take c by m equals omega naught square. C by m, C means spring constant, m means mass, which is equal to omega naught square. This omega naught is a new term. Actually it is what? Natural angular frequency. That is called omega naught. M is the mass. Similarly, I can take gamma by m equals 2k. Here k is a constant called damping constant. Damping constant. So instead of c by m, here c by m is there. I will be writing omega naught. Similarly, instead of gamma m, I will be writing what? 2k. So this equation changes to d square x by dt square plus, instead of gamma or c by m, what is c by m? Omega naught. So I can write omega naught square. Instead of c by m, here c by m is there. Instead of c by m, what I will write? Omega naught square x plus, instead of gamma by m, what I can write? 2k. Rest is dx by dt, which is equal to 0. And here one more thing, gamma by m is equal to 2k, therefore what is k? K is equal to gamma by 2m. This result we will be using. These two results we will be using later, and now we arrived at the differential equation of harmonic oscillator. Next one is we will be finding the solution. That will be the next class.